Hi, this is Mr. Anderson, and today I'm going to be talking about atoms and elements. This here is a picture of helium, and if we look at helium right here, you know that this is the nucleus here in the center. To give you an idea of scale, the nucleus, which is going to be this tiny bit right down here, is actually measured in femtometers, and so that is 10 to the negative 15th meters. In other words, this is really small, the angstrom unit here, but atoms are incredibly small. So in this podcast, what I'm going to talk about is the history of atoms, how it came to be known that there exists an atom, and then finally we'll talk about what are protons, neutrons, and electrons, and then how they're organized. Okay, so let's start a little bit with history. And so when we get into the modern day science, I love this guy. This right here is Mendeleev. And so what Mendeleev, a Russian scientist, was doing is he took playing cards and he would put information about each of the known atoms that we have. So maybe the atomic mass and properties of it. He'd write that on the playing cards, and then he just laid them out on a table. And what he finally figured out is that you put them in certain areas or certain order according to their atomic number, and kind of what we had was the modern day periodic table came out of that. If you really want to waste some time, this is a wonderful website to go to. This is periodictable.com. This was developed by a person by the name of Theodore Gray. I think he also started Mathematica. But the cool thing about it is that you can click on certain things, and so this is like carbon, for example. And what you can get are these wonderful, he's collected all these different atoms, all these different elements, and he has real world examples of it, and then a bunch of properties of that as well. And so you could waste a lot of time looking at that. And I have an app for this on my iPad that is just really, really cool. And so I love this picture here because it shows you all the different things. And what you find on here is that there's all these relationships. So if we look, for example, right here, copper, silver, and gold are all organized at the same point on here. And so as you start to play around with the periodic table, you find all this cool stuff. So let's go back in time a little bit. And so if we go through the important people in the history of the atom, in my class I don't think it's super important that you memorize all of these, but it's important to give us a little bit of context. And so let's first start with this guy. His name is Democritus, and he was Greek. And so what he essentially did is said, imagine if we take everything and then we divide everything in half. So let's say a block of wood, and then we divide it in half again. And we divide it in half again, 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 divide it in half again. If we just kept doing that over and over and over again, we eventually get something that's really, really small. And that really small thing he called atomos. And that just means atomos, I think is right. Undivisible. In other words, we can't break it down anymore. And so he's the first guy to come up with this idea of atoms, but wasn't a scientist. So then we fast forward a little bit, and this here is quite a bit actually. This right here is John Dalton, and John Dalton was doing studies, so he was measuring the mass of things, and he came up with our modern atomic theory. And so the modern atomic theory is this. He knew that hydrogen, for example, there would be 2 hydrogens for every one oxygen. And so he thought they were hooked together. They were like these little hooks in them that would hook those together. And he knew that you were going to have 2 hydrogen for every 1 oxygen that you're going to have. There was a specific ratio. But that first theory is that elements are made up of specific atoms, and they come together in a certain ratio to make a compound. So that sounds a lot like what we think of today. How's that different from our modern theory? Dalton thought they were just these round balls, so they weren't made up of different things. And so let's go forward a little bit. So who's up next? This guy right here, his name is J.J. Thomson, and J.J. Thomson discovered the electron. Let me show you how he did that. He used something called a cathode ray tube. So a cathode ray tube looks like this. You essentially have gas, and then you run electricity through it. And what you get is a ray that goes right through the middle of it like that. Now we have things in our house like a CRT, like your most of the televisions that we have is a cathode ray tube. It's a little bit different with the new TVs that we have today. But essentially what J.J. Thomson found is if he held a magnet up here, so if we put a magnet right here, what it did is it bent the cathode ray. So it bent that ray of electrons. And so he used magnets, and he also used electric fields. And what he found is that since we're pushing that when there is a like charge, he discovered, I think he called them corpuscules or something like that, but we call this today the electron. So he discovered the electron. What else did he come up with? Well, he came up with this, what we call the plum pudding. In other words, he thought that atoms, instead of just being that ball that Dalton believed, is that you had a positive charge inside it, but then you had all these negative charges inside here as well. So you had negative electrons that were kind of embedded in this positive ball. Okay, so let's go forward a little bit and tweak that. So this is Ernest Rutherford. Ernest Rutherford's famous for his gold foil experiment. And essentially what he did is took a bit of gold, so this is gold foil, and then he shot alpha particles out of it. And so alpha particles were shooting out through here, and they would travel through the gold. He had a little sensor on this side that would sense where the alpha particles go. Now, what is an alpha particle? Alpha particle is essentially like it's two protons and two neutrons. And so it's the nucleus of helium. And so what happened is, as these alpha particles came shooting through, some of them would kind of be turned to the side, but occasionally one of these alpha particles would come shooting right back. And when it came shooting right back, it kind of freaked out Rutherford. And Rutherford said it was like shooting a giant shell or bullet at a piece of tissue paper, and occasionally one of those bullets comes flying back at you. So what he had discovered was the nucleus. And he knew that it had a positive charge because those positive alpha particles were being shot back. So he discovered the nucleus. And so let's go to the Rutherford model. Rutherford model said that we had a positive charge in the middle, and then we had these negative electrons going around the outside. And so they went kind of zipping around the outside like that. And he realized that most of that space on the inside was that. It was mostly just space with a tiny little nucleus, because just a few of those alpha particles actually came shooting back out. All right, let's go next. Next, this is Niels Bohr. Niels Bohr, let's circle him down here. Niels Bohr is Danish. He works in Rutherford's lab, and the problem with Rutherford's lab is that they had discovered this positive charge on the inside and this idea that you have electrons going around the outside. But physics predicts that if you have a negative charge here and a positive charge out here, that quickly that negative charge is going to be attracted to it, and so the whole Rutherford model didn't really work. And so what did Bohr figure out? Bohr figured out that we've got this positive charge on the inside, we've got electrons going around the outside, but they go in specific orbits around the outside. So those electrons were not traveling here, but they had to travel in this specific orbit. And so that's the Bohr model, that you've got a positive nucleus and then electrons going around the outside in specific orbits. Okay, let's go next. Next, we get into the weird world of quantum physics. And so this right here is a man by the name of Schrödinger. Schrödinger is famous for Schrödinger's cat, if you've ever heard of that. And so what Schrödinger said is that electrons aren't particles, that they're actually waves. And so there's this duality. And so now we have this kind of competition between those people like Bohr, who said electrons are particles. Schrödinger said it was more like a wave. And so we had to sort out this. And so we eventually get to Heisenberg. But first, we've got this guy, Chadwick, and what Chadwick discovers is the neutron. It's weird, but it took us way longer to discover the neutron. That's because it has no charge, but it accounted for that mass. And then finally, we have this guy. This is Werner Heisenberg. And what Heisenberg figured out is that both Bohr and Schrödinger were right. In other words, what does an atom look like? It's got a positive charge, which we now know neutrons on the inside, but there's kind of this wave of probability out here. And so is an electron a particle? Yeah, but it's described by Schrödinger's idea of a wave. So we got pretty deep. But what is this? This is this quantum theory that we have today. It describes how electrons move.